And today we are going to see full gravitation formula. If you like my channel, please subscribe. It is very helpful to your preparation, whether you are preparing JEE or NEET, whatever exam you are preparing, this will be help you lot. The gravitation, first universal law of gravitation, the force of attraction or repulsion between the two objects F is equal to G times of m1 m2 divided by d square. So m1 mass, m2 mass, distance between these two we can take it as a d. So capital G is a universal gravitation constant 6.67 into 10 power minus 11 Newton meter square kg minus 2. The another word gravitation small g is equal to 9.8 meter per second square. So small g, the way to find small g is small g is equal to dash f I am taken as ma, so mg I am taken here mg on the earth is going to be g, it's g times of m1 m2 divided by, it is a radius of the earth, I consider one apple on the earth surface, okay. R is the radius of the earth, m1 is the mass of the earth, m2 is the mass of the apple, so radius square. So this is a mass of the apple getting cancelled. So small g is equal to capital G times of mass of the earth divided by radius of the earth square. Distance between these two is a radius only, apple radius I consider as a negligible. So using of this formula we can find small g is equal to 9.8 meter per second square. Next thing, gravitation in a height. So object at some height, what is the gravitation? Some satellite or some object is at height, what is the gravitation? It is g times of it is acceleration due to gravity on the earth's surface, which is going to be 9.8 meter per second square. 1 minus 2 height, it's the height of the object divided by, it is a radius of the earth, like this we can write, okay. The another thing, gravitation at depth, gd is equal to, g is the acceleration due to gravity on the earth's surface, it is 1 minus d divided by r. It is gravitation changing due to the height, gravitation changing due to the depth, okay. So d we consider as a, what is the depth of the under the earth, what is the depth, you need the gravity. Next is the orbital velocity, escape velocity, orbital velocity, it is a velocity which is a minimum velocity is required, the object has to be revolved in a orbit, so v0 is equal to gr, it is called orbital velocity. The second one, escape velocity, v is equal to, you can make it with 2 times of gr, or you can take it this equation also, it is the escape velocity, it is orbital velocity, or you can take it gm divided by r square whole square also, the same thing 2 times of gm divided by r square. This formula also we can take it. The next thing, gravitational potential energy, gravitational field and gravitational potential. These are the 3 formulas we are going to discuss, okay. First thing, gravitational field, okay. Gravitational field E we can take it as a gravitational field, force per unit mass we can take it as a gravitational field. Force already we have, this is a force, it is a g times of one mass will get cancelled, m divided by d square, it is a gravitational field, okay. Gravitational field formula. The next formula, gravitational potential energy, so U is a gravitational potential energy, so we can take it force into displacement, if example only I am doing this, okay. So F is it is g times of m1 m2 divided by d square into d, distance I am taken, dd can cancel, so gravitational potential energy, usually potential energy will be minus g times of m1 m2 divided by d, otherwise you can take it as a r also, because we are going to consider gravitational potential energy on the surface of the earth, okay. So it is g times of m1 m2 divided by r, it is a gravitational potential energy formula. The another thing, gravitational potential, so potential is going to be called as a voltage, so voltage is equal to work done by mass, okay. Already we know work done is the minus g times of m1 m2 divided by r divided by m, so mass getting cancelled, gravitational potential is equal to minus g times of m divided by r, okay. So far we discussed, these are the formulas, okay. If you like my channel, please subscribe. So first we saw F is equal to g times of m1 m2 divided by d square. Second we discussed g is equal to g times of m divided by r square, okay. The next thing, we got as orbital velocity and escape velocity. So orbital velocity is a root times of gr, escape velocity is a root times of 2gr. The next formula we discussed, it is gravitation at height. It's g times of 1 minus 2h divided by d. Gravitation in depth, so gravitation in depth is equal to g times of 1 minus d divided by r. The next thing, gravitational field is equal to it is f divided by m, that which is going to be a g times of m divided by r square. Next thing, gravitational potential energy, it's a minus times of g m1 m2 divided by r. The next thing, gravitational potential V is equal to minus g times of m divided by r. Okay, these are the formulas we learned. The remaining formulas is there for Kepler's law, time period of the satellite. Okay, this geostationary satellite. These are the total energy is in orbit. These are the concept we left. Okay, the next concept we are going to learn, it is what is a total energy. Total energy is equal to kinetic energy plus potential energy. Kinetic energy of mv square potential energy minus g times of m1 m2 divided by r. So mv square, using centripetal force, mv square by r is equal to gravitational potential energy g times of m1 m2 divided by r square. Centripetal force is equal to gravitation force. This what getting cancelled, so this will get m. It is a mv square. Instead of mv square, you can write g m1 m2 divided by r square. m1 m2 divided by 2 times of r get cancelled. So here only r will be there. So instead of mv square, I wrote this equation. Okay, minus g times of m1 m2 divided by r. This total finally will get what is the total energy in orbit. So minus g times of m1 m2 divided by 2r. So I got what is the total energy also. The next thing we are going to discuss about what is a Keplers law. There are 3 laws is there in Keplers law. It is a first law. It is based on when the point it is close to the sun. When the earth is close to the sun, we can take it as a pre-g. When it's a far distance, we can take it as a apogee. Okay, it is a first law says when the earth is close to the sun, we can take it pre-g point. When it's the earth is a longer distance to the sun, we can take it as a apogee. The second law, total area with respect to the time is going to be constant. Total area swiping out. Okay, when the earth is revolving from one place to another place, the swiping area is going to be constant. dA by dt is constant of times of it is L divided by M. L is constant, M is constant. So total area of swiping out is also constant. So this is going to be a constant, is representing as a second law. Okay. Now Kepler's third law. So Kepler's third law is representing squaring of time period is going to be cube of directly proportional to cube of radius. Okay. This equation we are going to get, it is this equation we are going to get when the earth is revolving around the sun. Okay, when the earth is revolving around the sun, centripetal force is equal to gravitation force. Centripetal force is equal to gravitation force. So this is going to be mv square by r centripetal force, gravitation force g times of m divided by r square. R is here, it is a orbital radius. Okay, it is a mass of the earth. Okay, it is a mass of the earth getting cancelled. This is a mass of the sun. Okay, so 2 mass is there, one is a sun mass, another one is a earth mass. Okay, so r square get cancelled, v square is equal to g times of m divided by r. This what will get velocity in a circular motion, its displacement by time. Displacement is a 2 pi r divided by t. Okay, just I am going to substitute in this equation. So let's see what we are going to get. Okay, so this is a final formula for the Kepler's law. It's a third law. Okay, so it is a v square, so it is 2 square pi square r square divided by t square is equal to g m divided by r. R I am taken this side, t I am taken this side. It's 4 pi square r cube is equal to t square divided by gm. So t square is directly proportional to cube of the radius. It is a representation of third law. Okay. The next thing, time period for the geostationary satellite. Time period for the geostationary satellite, time is equal to question mark. So velocity is equal to, in circular motion, geostationary satellite is 2 pi r circumference of the circle divided by time period. Time period is equal to 2 pi r divided by v. Okay, we can find the time period is 24 hours for the geostationary satellite. Okay, so it's a most important concept based on the gravitation, mostly we discussed all the formulas. The final review I'm going to give what are the formulas is there in a gravitation. The first one, F is equal to G times of m1 m2 divided by d square, otherwise r square, anything you can take it. Okay, distance between the two objects, that's it. Okay, force we got. The next thing, small g is equal to gm divided by r square, acceleration due to gravity, which is going to be 9.8 meter per second square. The another value g is 6.67 into 10 power minus 11 newton meter square, it is a kg minus 2. Okay, so then next thing, it is a gravitation at height, it is g times of 1 minus 2h divided by r. It is acceleration due to gravity, it is a height of the object. Okay, it is a radius of the earth. The another thing, gravity at depth, the next formula, gravity at depth. So gravity at depth is equal to g times of 1 minus it is d divided by r. It is acceleration due to gravity, it is the depth of the object, it is a radius of the earth's surface. Okay, the next thing, we can take it as a gravitational potential, gravitational field is going to be g times of m1 m2 divided by d square, or d, so this mass we won't get, divided by d square. Okay, because gravitational field is the force per unit mass, so it's going to be r square or d square, anything will be. Gravitational potential energy minus times of g m1 m2 divided by r, and the gravitational potential voltage V is equal to g times of m divided by r. Okay, then total energy is equal to total energy, kinetic energy plus potential energy minus times of g m1 m2 divided by 2r is a total energy. The next thing, Kepler is first law, it is a representation of pre-g and apogee point. Okay, close point and long distance point. Okay, Kepler is second law, it's representing area of swiping out with respect to the time is equal to constant. It's representing in a representation in the second law. Kepler is third law. Okay, third law, squaring of time period is directly proportional to the cube of the radius. Okay, so this are the very important formulas in gravitation. Okay, so if you are having revision in this formula, definitely you can get the questions. Okay, yeah, I forgot to write escape velocity and orbital velocity. Escape velocity is root 2 times of gr is equal to orbital velocity is the root times of gr. Okay, these are the very important formula based in gravitation. Okay, the another formula, the relation between the weight on the earth surface and the moon surface. So gravity on the moon surface is 1 by 6 times of gravity on the earth surface. Okay, the same formula you can write, weight on the moon surface is 1 divided by 6 times of weight on the earth surface. Okay, this formula will get gravity on the earth surface is g times of m divided by r square. It is for earth, it is for earth. The same formula, gravity on the moon surface, g times of mass on the moon and radius of the moon square. When we are doing this two division, gravity on the earth surface divided by gravity on the moon surface, will get this calculation will get as a 6. So gravity on the earth surface is 6 times of gravity on the moon surface. It's a very simple calculation. Okay, if you like my channel, please subscribe. Thank you for watching my video. Thank you everyone.